elements. So what we're going to do first, okay, we are going to identify we're going to identify the moments, the bending moment, okay, we identify the bending moment. We are going to identify what are our shear forces and torque acting on elements H and K. Okay, so H and K are our point of interest. Okay, so I'm going to write down 3 basic steps that you have to apply always. Okay, if you don't apply these 3 basic steps, everything can be viewed very confused. And again, when you see the solution manual, okay, they already know these 3 steps in one form or the other. Okay, but I'm going to make it very simple for you. Okay, remember, this is a 3D analysis and we are solving this on a paper. And on when you write on a paper, it is 2D, right? So I'm going to teach you a way that to analyze this that is foolproof, that you cannot make any mistake. Okay, if you follow these steps. Okay, so rule number 1. Okay, rule number 1 is you have to locate the orientation okay, of the orientation of the transformation relative to the position of the elements. For this example, it's pretty straightforward because we know that this direction is your X, this direction is your Y, and this direction over here is your Z. Okay, you know that. Okay, and then the second one, okay, the second one is identify the neutral axis okay, relative to the elements okay, relative to the elements, then identify okay, then identify the moments, the bending moment, which is M. You identify the shear force, which is your V, and your torque, which is your T. Okay, so the difference between moment and torque is, so moment, the units are the same, by the way. Okay, the moment, the units for moment and the torque are the same. So moment is equal to force multiplied by perpendicular distance. So the unit over here, right, we know is Newton meter or pound inch. Okay, that's moment. Torque is equal to force times radius. Okay, so the units are the same, right? The units are, the difference is the deformation. Okay, the difference is the deformation pattern, right? What do I mean by deformation pattern? Okay, so if it's bending moment, so if it's I'll try to draw this in 3D. Okay, if it's bending moment, right? So this is our change color. Okay, so this is our neutral axis. Okay. If and then if a load is applied in this direction, right? The deformation looks like this. Okay, the deformation looks like this. Right. So this is how your structure will deform. Right. So that is your deformation pattern. Right. So this is due to bending moment. Right. So you have force multiplied by your perpendicular distance, what I call it D. Okay. In torsion, right? Again, the same shaft, Hey, right? Now, this is the force, and then this is the radius. Okay, right? So you can see that it's not on the same plane where you calculate on the radius. And the deformation pattern, I want you to see this is the neutral axis. Okay, this is our neutral axis. So the neutral axis for the bending moment, it shifts, yes or no? It can be a smiling face or a sad face. In a torsion configuration, the neutral axis remain in the same position. Okay? A lot of times, a lot, I mean, as I said, I've been teaching this for a long time. This mistake is very common to identify the bending moment. What is a bending moment? What is a torsion? You have to visualize the deformation. If you cannot visualize the deformation, you mix both of them up. Okay, that is why I don't want you all to just plug in the formula. Okay, I could teach this course very, very differently. I can make use of vector, right hand rule, okay, and make you guys just apply the formula and there you go. I did not do that. I insist that when you look at the moment vector, the head of the moment vector is compression, the tail is tension. Because I want you all to visualize what? The deformation. That's why this course, I told you what, don't worry about the plus or minus. You look at the deformation. Okay. And then the third rule that you have to apply, okay, the third rule. So we are in the second rule. The third rule that you have to apply is you have to base. Okay, so based on, I'll explain third rule later on. Okay, I'm going to write it out. So it's going to base on certain view orientation. So what do I mean? So do not analyze the dot and crosses. I'll explain this later. Okay. So we have been sitting here for 1.5 hours. What I will suggest, okay, applied force on torsion part is different from bending moment. Yeah, it's different because that's how they define what is a torque and what is the bending moment, Azam. Okay, this is the difference. Okay, a lot of times we look at the formula, you will look at force times by perpendicular distance. Isn't perpendicular distance relative to the radius are the same thing? It is, right? Because the radius is also the perpendicular distance of the applied force, right? Okay. So let's go for a short 5 minutes break. Okay, let's go for a short 5 minutes break. Then we come back. Okay, as I said, I have to run at 11. I have a doctor's appointment. And then, yeah, take a 5 minutes break and we come back again. Okay.